all, my heartfelt thanks to our principal ma'am and IPC coordinator and other faculty members. So my seminar topic is a comprehensive review on multi-carrier modulation scheme. So the multi-carrier modulation scheme, that is 5G technology, introduced that what are the multi-carrier modulation techniques available in 5G technology. We know that what is the modulation technique. Generally, in modulation technique classified two in basic general. In easy background, people know very well. So, what is the modulation technique? So, it's classification of two. One is analog, and the second one is the digital modulation technique. So, this is a multi-carrier modulation technique is introduced and enabled for 5G technology. So now we are using for 4G technology. So before going to what is the history of the wireless communication system, that wireless communication system that then we called as cellular communication system, mobile communication system, etc. So this is a actual topic. This topic is relevant to the wireless communication background. So this seminar topic, just I introduce what is the history of the. So this is my flow of the presentation. The first one, what is the introduction of the mobile generation? So as we know very well, so what is the generation of the mobile system? So first generation and second generation and third and fourth, fifth generation also going to implement. Then sixth generation also going for the research is going for all over the country. So the second one is what is the evaluation of the first generation to fifth generation? What are the parameters? What is the range? What is the data rate? What is the spectral efficiency? What is the advantage? How the technology is developed to one generation to the next generation? So that part we are going to discuss about that. What is the evaluation of 1G to 5G? Then after that, what is the comparison? What is the comparison of the 1G to 5G? How the technology is developed in as of now. Then what is the different kind of them? I am going to a little bit deep of the 5G technology. So everyone should know that what is the 5G technology is going, what is the 4G and difference between the 5G technology. That is very important for everyone. So what is the different kind of the band is used for the 5G technology? That is we know very well. Generally the band sense higher band is the lower band and mid band. If you are applying the lower band, what happens? If you are applying the higher band, we are applying the mid band. So what is the frequency? If you are applying the lower frequency and higher frequency, so what terminology will happen? So that part we are going to discuss about the different band of 5G. Then what is the characteristics? What is the advantages of the 5G technology compared to the 4G? Then what is the advantage and the limitation? Then what are the applications of the 5G technologies? So and last one, just I introduced that what is the multi-carrier modulation system in 5G network. So this is my just touching my research area, and last one I conclude my overall presentation. So next one is first of all to introduce the what is the history of the mobile generation. The mobile generation, the technology used for mobile generation or mobile communication or wireless communication or cellular communication, both name are same. So the first generation is just developed from 1980s. The first generation, the data rate less than 10 kbps. That is the kilobits per second of the data rate speed. So that is very low. So the introduced by 1980s. Then after that move on second generation. So the first generation, I think everyone aware about the cordless telephone. It's like it's a cordless telephone. So one antenna is there only for calling purpose, and the rest of them nothing. The second generation is developed the technology, both voice and text messages adopted. That is the second generation. So that is the year is developed on 1990s. In 2G sustaining more in all over India. Why? Because the 2G technology is introduced by the system standard is GSM. I think most of them had about the GSM system, global system for mobile communication. That system is introduced in the second generation. That is, the data rate is 64 kbps. Then after that, the system is little developed to the GPR, General Packet Radio Services. Introduced, the data rate is much higher than compared to the GSM. That is, the GSM is used for 64 kbps and GPRS is used for 171 kbps. Then after that, again the technology is upgraded and the data rate also increased. That means the data rate of speed also increases in X technology. That is the 2.5. The 2.5 is used for Edge technology. What is the full form of Edge? Is the enhanced data of GSM evolution. So that is called E. So maybe you are in 2G technology at the time. The E is coming in your mobile phone. The tower range is there. So the tower range nearby, the E is coming. Up arrow, down arrow is coming in your mobile phone. Somebody is seeing that E. So E is called as Edge. That is for 2.5 technology. So before the 3G technology, so the mobile phone you have to see that E. That is up arrow, down arrow symbol is seen there. So that is a 2.5. That is after that the mid of 2000 that introduced to 3G technology. The 3G technology is what is the advantage over the 2G is the internet connectivity and also faster data rate transmission and also the multimedia support. So the multimedia support is introduced to only 3G technology. So that is what the most advantages are compared to the 2G. Then after that, the 4G technology also introduced in 2010. That is all internet application. So that time, what happened for the mobile companies? The mobile companies to enhance the mobile phone. So what need for the 4G technology? That is the requirement is happen for all the mobile companies. So what happened is after that the mobile companies to improve the mobile phone. So what main thing is the huge storage capacity is needed for 4G technology. So that is upgraded in every company, the Samsung or Nokia or Realme, whatever it is. The first one is a huge storage capacity and high processing capability and also the advanced camera. So these three things are very demand for the 4G technology. So every company is adapted to the three characteristics to adapt to 4G technology. Then after that, now the research is going for 5G and 6G also. So some data rate, the speed and everything is changed over. Then finally 6G is what the research is telling that all the devices will be able to connect to the internet. So that is the main advantage of the 6G technology. So the next part is what is the evaluation. So already I mentioned that the first technology is used for, I already told very clearly, the modulation technique is only two, one is analog and digital. So the first generation is used for only the analog system, that is a voice based, that only the limited range and the speed is very less than 10 kbps. The latency, what is the meaning of latency? Latency is nothing but minimum delay or lag in the data transmission between the two devices. That is the name is called as latency. So always we are expecting the low latency, okay, in terms of milliseconds. So that is the main need for the latency. But here there is only latency. The maximum data is less than 10 kbps. The second generation is used for digital. The first one is analog and the second generation is used for digital. So nothing but the maximum data rate is 64 kbps. Then in between 2.5G, H also increased to, the data rate is increased to 473.6 kbps of data rate is improved for 2.5. So here is used for both voice and text message in second generation. Third generation is used for the maximum data rate is increased in terms of kilobits per second. This move for megabits per second, 2 Mbps. Kilobits per second, megabits per second, gigabits per second and terabits per second. So this is a hierarchy of data rate. The speed, that is a unit, kilobits and megabits and gigabits and terabits. So okay, then the 3G is used for the voice data, internet, mobile phone. All the multimedia is also supported in video calling and all implemented in 3G technology. So therefore, then after that the 4G is also introduced, that so LTE. Now your mobile phone you are seeing that LTE. So earlier it was E. Then upon now here was there the nearby the network. Now we can see that in 4G now the system is introduced that LTE, long-term evolution, that the technology is used for in 4G technology. The latency and maximum data rate also 450 Mbps, here the 2 Mbps. Then after the 5G, the people are going to expect it, so very less latency. That is the main advantage. Only this 1 milliseconds and maximum data rate is in terms of megabits to in terms of gigabits per second. So see the technology is improving. Here is less than 10 Mbps, 64 Mbps, 2 Mbps, 450 Mbps, and then after that the 5Gs are expected to greater than 1 Gbps. In 6G also researchers telling that 1 terabits per second. 1 terabits per second, that is the speed. The downloading speed is also telling the 6G technology. So now it's next going for what is the technology is used, what is the frequency range. So the 30 GHz used for 1G, 1.8 is a gigahertz range, 1.6 to 2 and 2.2 to 8 gigahertz, and 5G is the 30 to 30 gigahertz. And also this is a multimedia access system. That is the frequency based multimedia access. Here the system is used for here both TDM and CDM, and also here also 3G and 4G also used for wireless technology, and 5G also used for the multi-carrier modulation systems also introduced in the ITU. Okay, there is a core network, and also the what is the technology is used for the here is a advanced mobile phone system. GSM I already mentioned that. wideband CDMA, LTE is now long-term evolution 4G, and MIMO is multi-input and multi-output, and also millimeter wave communication. That is a 5G technology. Then after that, so see that this is very important 5G. Here is used for lower band, mid band, and high band. So see that look at the diagram. So coverage and throughput. So always very important for the every communication is very important is coverage area and range, and also gain and efficiency. That is very important parameters. So see that if you are using the lower band, the coverage is much higher, but throughput is very less. So the frequency band is used for 450 MHz to 1 GHz. Because the low band, if you are using the low band, so the lower frequency having the narrow band, and also which is the limited data transmission over the at the given time. So therefore, the coverage area is broad coverage area, but throughput. What is the meaning of the throughput is nothing but what is the speed, what is the actual performance of the speed. That is the throughput. So that time only limited speed. The coverage is more, but throughput the data speed is very less. If you are using the mid band, so mid band is also good balance between the coverage and throughput, but and also on capacity also. Then high band in terms of millimeter wave. What problem is the high band? If you are using the high frequency range, so only the short coverage area and also poor penetration also, and throughput is also very limited range of the data speed. So that is the difference between the low band, mid band, and high band. This is research is going on. So the next one is, so what is the 5G characteristics? What is the peak rate and throughput? Throughput is in terms of the speed, 10 Gbps per second. Mobile communication 500 km per Hz is nothing but the data connected to the users. So traveling to 500 km per hour. For example, if you are traveling the train or if you are traveling the car, so 500 km per hour the data speed is there in 5G technology. So that is the 500 km per hour. So the energy efficiency also 90%, reliability is there. Mobile data volume, tens of terabits. Here this data volume is nothing but download and upload capacity. So that is nothing but mobile data volume. And the latency also very low. That is we are expecting that 5 milliseconds. And service deployment is nothing but useful for the futures and applications. So we are making for using the futures and applications also adapted to the 5G technology. There is a service deployment and connected device 1 million per kilometers. It's nothing but 1 million connected devices to 1 square meter. That is the meaning. That is a 5G advantage. At the same time, in 4G technology, 2000 connected devices to 1 square kilometer. That is the difference. Here is 1 million. So 1 million connected devices to 1 square meter. So in 4G technology, 2000 connected devices to 1 square meter. So that is the difference between 4G and 5G. This is very, very important parameter characteristics. Connected devices 1 million per kilometer. So square kilometer. So that is called as square kilometers. So this is a 5G characteristics. Then after that, we go for what is advanced, increase the connectivity, so also we are expecting or every month, and enhance the experience also, the real-time collaboration also is needed, support the high quality of the content and enabling the new applications and services also adapted to the 5G technologies. Then after that, what is the limitations? High infrastructure cost compared to the 4G technology. So that is true that still the research is going on. So how to reduce the cost? So installation cost, for example, everywhere we are setting the cell towers. So that is the base station we have to set up. So the high infrastructure cost is there, and security risk. The security risk is nothing but there's hacking and cyber attacks and also. And privacy concern is very important for us. And device compatibility also is very important. And health concern. Health concern in sense of virtual education or health care, and also the so many things is there to concentrate for the health concerns. So this is the limitations of the 5G technology. Then what is the application also is used for health sector and agriculture land side also. Then IoT is multi-input and multi-output also connected for IoT, and manufacturing also used for everything. And logistics is mainly used for vehicle-to-vehicle communication or vehicle-to-infrastructure communication also used for logistics is mainly used for shipping. So suppose shipping in that time is tracking is very slow, so that time is used for 5G technology is very easy to access for the shipping side. So that is the advantage of the 5G. Then go for this introduction of the multi-carrier modulation scheme. So the multi-carrier modulation scheme is introduced that this is a OFDM, that is orthogonal frequency division multiplexing, and a filter, universal filter multi-carrier, filter bank multi-carrier, and the generalized frequency division multiplexing. So the out of these four, so I am taking my research. So UFMC, this is the I am taking for the universal filter multi-carrier modulation system. So this is my research topic, and also I am going to detail the discussion. So my research is going on. Also at the end of the stage is my research. So what's happening in the all four multi-carrier modulation scheme, only one drawback is very common. I will tell later what is the drawback. So that drawback we are going to rectify. So once rectified, what are the things to be improved? So that is my research area. So then, so coming to first one, this is a 4G technology also adapted. That is the orthogonal. Orthogonal, we are n number of subcarriers we have to transmit to the multiple orthogonal subcarriers. What is the advantage is high data rate transmission. We are either high data rate. That's what we are going for orthogonal. So normally we are using for frequency division multiplexing. Orthogonal cells we are using for multiple subcarriers. So for enabling the high data rate. So that is the concept of this is a general block diagram. So the very important for high power amplifier. So all the input is giving for input bits and modulation and signal to parallel converter, and also IFFT, the DC converter, you know very well. Then PAC, and after that giving the signal to high power amplifier. So once they give the transmitter signals once given to the high power amplifier, so getting for high peak level, the fluctuation is happen. So that fluctuation is given to high power amplifier, the totally the system is the gain and efficiency all will be affected. That is a common factor for all multi-carrier modulation scheme. Not only the OFDM, even UFMC, GFDM, FPMC, all the power is finally the transmitted signal once given to the high power amplifier, then the peak, the fluctuation, that is high peak level is once giving the high peak level will be occur. So that transmitted signal, the high peak level directly given to the high power amplifier, the total gain and efficiency will lost. So our research is how to reduce the peak level and how to improve the gain and efficiency. So once the gain and efficiency once improved, then automatically coverage area and also the capacity and also everything will be automatically improved. So that is very important for transmitter section. So that is the main intention of this my research. So this is a high PAPR, that is a peak to average power ratio. So what is a PAPR definition? Is high peak definition, the ratio of the high peak power by divided by the average power. So this is a very important factor for PAPR. So this is a common drawback of the equal system. So this is my actual research I am doing for the universal filter multicarrier system. So here is used for the entire bandwidth is divided into the multiple subband. So each subband we have to fill the subcarriers, and also each subcarriers we have to do the separate filters. So that is the main advantages of universal filter multicarrier. The spectral efficiency. So what is the meaning of the spectral efficiency is data rate. We are getting the data rate. How to find out the spectral efficiency means net data rate divided by bandwidth. Net data rate in terms of flow bits per second, data rate in terms of unit, and divided by the bandwidth in terms of the bits. So that is the meaning of the spectral efficiency. And also here everyone is exported for minimum delay, that is called low latency, and also flexibility is there and reduce the interference. This system also the disadvantage is only because of the high peak to average power ratio problem is occur. So once occur this occur in the high power amplifier, the amplifier is decay the bigger rate and also increase the outer emission. So many things will happen. So some applications also used for ultra reliable low latency communication and M2M communication and enabled mobile broadband, and so many applications is there in the function system. This is a general diagram of the function system. Then after that we will go for filter back multicarrier. So here is each carrier we have to filter, we have to apply the filter. So that is the main drawback of FDMC. So most of this FMC also one of the research is going on. So the most of the identity access memory is accepted for the UFMC system only. Here is used for the FDMC is not recommended for that much. And here are some advantages or disadvantages there. And also GFDM also is used for the multi-bit subcarrier and also used for circularly pulse-shaped subsymbols per subcarrier is adapted to the GFDM technology. And also this GFDM also the drawback is the same thing. So high PAPR also will be occur, and also some applications also there. So the time consumed I am going very fast. Then finally, what is the comparison of all the multicarrier model system is used by 5G technology. So the basic what is the main concept, and here it's used for orthogonal subcarrier. The FDMC is used for each subcarrier we have to filter. Here is used for the entire bandwidth is divided into the subband. So each subband we have to filter. That is the main advantage. Once do that, we are getting the good spectral efficiency. And also the implementation complexity is there, but here there is no any adding and subtracting, there is no need for that. So the simultaneously will transmit the signal. And here we have also the block based that is subcarriers direction is going for GFM technology. So these two are not recommended, say FDMC and GFMs, but some research is going on. The few papers only are coming for the journal papers. So the 4G technology is used for YFDM and UFMC also used for 5G. But some people are saying that the OFDM, so little modification also is applicable for 5G technology also. So this is a basic concept of the spectral efficiency I already implemented. This is very important parameter. Then out of band emission. If you are sending the signal, some leakages happen for the signal. So once leakages happen, then automatically affect the performance of the system. So then what is the complexity? If you are doing the complexity, so some difficulties happen for the in the portal system, and latency also I mentioned clearly what is latency is nothing but we are getting the minimum delay. If you are downloading the any files or anything, we need the low latency. That is a minimum delay. So and also synchronization, that application side also used for all the multicarrier system. So finally, so what happened is this parameter I am going to take my results, the peak to average power ratio in here all the multicarrier modulation system is a common thing for very high. So rest of the things also I am going to concentrate in my research. The main concentrate is the peak to average power ratio. So this is the main thing. Then after that, so what are the minimization techniques are available? So okay, the problem is occurring on multicarrier modulation system. Then next we going for, so what are the minimization methods available in the system means there are distortion and distortionless method. So different kind of the method is available. The distortion method and the distortion method and coding method also is possible. So I am going to concentrate with the distortion method. So this is my already the two paper in the journal and waiting for the acceptance. And this is the last slide. So this is the, what is the definition of the peak to average power ratio? I already mentioned that the ratio of the if you are setting the signal, so what is the peak level? So divided by the average power. That is the peak power divided by average value of the system. In terms of dB, 10 log base 10, that is the maximum value. X of t is the input signal, then divided by average x of t signal. Here you can see that it's very clearly mentioned that here the one of the power amplifier diagram to the here and the purple and the blue the two signal is there. This signal is the wave signal is directly giving for power amplifier. So that time what happen is high peak level will be occur. High peak level will be occur. So this signal is directly given to the power amplifier. That is a transmitter section. Then after that the BME reduction, the signal is coming to the peak level is very less. So what we do is here I give a input back off. This is a G1 and this is a eta 1 is efficiency, G is a gain. So here is a two things is there. First one, IP01, what happened is the IP1 input back off is very high. So this is the curve of the gain versus efficiency. This is a power amplifier characteristics. So input back off, first the input back off is very high. So that time is the efficiency and gain is very small. So we are getting for high linearity. That is a high peak level we are getting. Then after that, the second part is the input back off is very low, then gain and efficiency is high, we are getting the small linearity. So therefore, we are doing the signal, therefore wave signal is applied, then transmitted to the finally given to the high power amplifier. So the finally this peak level will be affected, the total system is affected by gain and efficiency. So once reduction of the behavior, so we are getting the more gain and efficiency. That is a difference between the blue line and purple line. That is one of the important concept of peak to average power ratio. So let me conclude my presentation. It's all about the only the transmitter section. I am going to concentrate in the high power amplifier. So that high power amplifier efficiency is very important. So why we are concentrating the more gain and efficiency? This means improve the range and coverage. This is very important for everyone. When using the mobile phone, the coverage range and the coverage area, that is very important. So once directly we are giving the signal to the power amplifier, some fluctuations happen, then automatically the system is efficiency gain will happen. Once reduce the peak level, then we are getting the more gain and efficiency, and also the communication side, mobile signal side, we are getting the good range and coverage area. So this is my message area I am doing for the research. Simultaneously in most of the parameters also I am going to take not only the behavior only. So additionally I am going to concentrate what is the beta rate and also the spectral efficiency, what is the outer band emission, what is the error vector magnitude. So many parameters I am taking in the research is still going on. It's a very good topics for doing the research. So thank you very much for listening my presentation. This is my small messages conveyed to all. Thank you.